Hello friends, welcome back to MathsGenii, and today we're going to start with differentiability. If you have not watched the derivatives and the continuity video, I recommend please go watch that first and then watch this video. Now I'll just quickly walk you through what is the flow of this video. So you can anytime skip to the part that you want, but I recommend to follow it along. So first we will be seeing the theorem on how we can use the continuity concept, and we'll discuss the theorem in detail. Then we are going to see what is the derivatives of composite function, what is chain rule, how to use that with examples, then implicit function, then inverse trigonometric function, and lastly how to find the second order derivatives. So without wasting further time, let's jump to the first concept, which is the theorem. Now, you have studied limits in class 11th, and I've also uploaded the limits video so you can watch that if you want to know the details of how this formula that I'm writing came into existence. So, limit. So, we already know this. Limit x tends to c f of x minus f of c upon x minus c is equal to f dash of c, that is the derivative. F dash means f dash is derivative. This is how you denote the derivative. I'm sure derivative also you guys must be familiar with if you are looking at this video. Okay, now we will start off with the basic concept. Okay, uh, so this is your if I say I have f of x minus f of c as my initial function, okay, and I say that let me do one thing. I will take f of x minus f of c as it is, and can I multiply and divide by any number I want? It is anyway going to get cancelled. So let me multiply and divide by x minus c because I'm just going at this expression. So x minus c will get eventually cancelled. So I can add a new term very easily, right? Now look at the catch here. Therefore, now we are going to apply the limits to the same concept. Okay. So what I'll do is let me just copy this one. We are just going to add limits to this. So limit x tends to c and a big bracket. Similarly, here too I'm going to have limits x tends to c and a big bracket. Now we all know the split rule of the derivative. It's of limits. It's very simple. Limit will go to this. Limit will go to this. So it will become limit x tends to c f of x minus limit x tends to c f of c, and then limit will go to this term and this term, correct? Now look at the logic that we can apply. Can you see anything that can be substituted or anything that is coming to your mind? Okay. Now carefully observe this bracket. Can I say that this is the definition from 1? Okay. From 1. This is the definition of f dash of c. Limit x tends to c, and this entire term can be replaced as f dash c. Correct? Now let's get back to substitution. Whenever you substitute limit, so if you substitute limit here, what will remain is instead of x, you will put c. C minus c will become 0. Correct? And here what do you have is limit x tends to c, f of x minus limit x tends to c, f of c. Anything into 0 is 0, correct? So this will remain as it is. Now this minus will go that side and become what? Plus. So hence you get the definition of continuity. This is the definition of continuity. You can go back to my continuity video and watch it. So therefore I can say that f, the function f, is continuous at x equals to c. So we started off with the definition of derivatives and we ended with continuity. So therefore we can say that f is differentiable at point c. Then it is also continuous. If any function is differentiable, it is also continuous. But vice versa is not true. If some function is continuous, that then we cannot necessarily say that it is differentiable. But this theorem stands true, which states that function f is differentiable at c. If a function is differentiable, then that function is continuous. Okay, now let's look at composite function. The word sounds to be a very big word, but it's a very a common sense kind of a statement. So what is a composite function? Composite function is where the output of one is the input of other. So for example, you have something like this. So your output will be this. So what does it say is where the output of one is the input of other. Okay, so this is a composite function, a function made up of two functions maybe. So this is the example of composite function. So let me just take one example how to find the derivative of a composite function. So your question is y is equal to sine x square. Okay, now I want to find dy by dx, that is the derivative. Okay, now when you go back to your formula sheet, I'm sure you already have a formula sheet. So sine x derivative, the derivative of sine x is what? Cos x, correct? So can I write, so this is, I'm explaining chain rule also. This is called as chain rule. Now what is chain rule? When you have, so this is in a very layman terms that I am telling you about chain rule so that you always remember what it is and why it is used. When you have anything other than x, example, here you had x square, but I don't know what is sine x square formula. I know sine x formula. So this is the condition where chain rule comes into picture. Okay, now sine x square. Do I know? So just ignore x square for a while. Let's just assume. Let's assume this to be x in your mind. This, let's assume this to be x. Okay. Now normally find the derivative. What is the derivative of sine x? Sine x derivative is cos x. I'll write cos x. But do I have x here? No, I have x square. So this is the extra term. So whatever function, what does chain rule states is that whatever function you are assuming as x, multiply the derivative of it. So x square I had assumed as x, right? So I have to multiply the assumed function's derivative. Okay. Now this will be cos x square as it is. What is the derivative of x square? 2x. Now this is my answer in simple two steps. Okay. Now let me take one more example so that there is no confusion at all about the chain rule. Okay. So here also if you see, do you have a normal x here? No. So I will have to assume this bracket. Assume this bracket to be x, Correct? Now, in the retrospect, what I know is derivative of tan x is what? Derivative of tan x is sec square x. Okay. Since I am assuming this to be x, so I will write derivative of this term I have to find, right? So I will write derivative of tan x is nothing but sec square x into the derivative function considered as x. Okay. So always remember, for chain rule or anything other than x if you have, so I'm just writing it down. You can take it as a note somewhere. Anything other than x, apply chain rule. What is chain rule? First step is assume it to be x. Find normally. Assume it to be x. Assume the term to be x and find derivative normally. Find derivative normally. Okay. Then multiply it by the derivative of the function considered as x. This is the most important step. Multiply with derivative of function assumed as x. Okay. As we did here, we multiplied the derivative of the function assumed as x. So let's just find the answer quickly. This will remain as it is. We have already found this out. And what is the derivative of 2? 2 is in multiplication, 2 is a constant. So what is the derivative of 1? X. Derivative of x is 1 plus. What is the derivative of 3? Any constant derivative is 0. So you have your answer as 2 ones are 2, 2 plus 0 is 2. So 2 sec square 2x plus 3 is your answer. So now let's take a little tougher question. Okay. Now in the bracket you have something very odd. Okay. So firstly, you will go back to your formula chart or your memory, right? So sin x derivative is cos x, correct? And cos x derivative is minus sin x, correct? So this is what we know from previous class. Now what is new is chain rule. Okay. So I'm assuming this to be x. Okay. Assume this as x. So I'll normally find the derivative of sine. Okay. So dy by dx is equal to. Let me just find the. Okay. Now we are in a good position. Okay. So sine derivative. Sine derivative is what? Cos. So I'll write cos. But you have something in the bracket instead of x. So I'll write this. So what is the catch? You had assumed this to be x. So multiply it with the function considered as x. So this was considered as x. So I'm multiplying this with this term. Again, do you have a normal x inside the bracket? No. Do you have it? No. So again, what will you have to do? Assume. Assume this to be x. Okay. Now what will you do? This will remain as it is. What is the derivative of cos? It is minus sine x. But you don't have x here. You have assumed it. So whatever you have assumed, you will have to repay. So now repay. So multiplied with the function considered as x. Now x square derivative we know. So now no need to assume anything. So this remains as it is, this remains as it is, and the derivative of x square is 2x. So this is your final answer. Now let's move ahead with derivatives of implicit function. Implicit is you have x also and you have y also. Okay. So this is the question. Now, till now, you have never come across sine y. You have always been solving sine x. Sine x derivative is cos x. This is what you've always been doing. So let's just see how to find it out. We differentiate with respect to x. Okay, with respect to x. So x is the real hero in the picture. So x is your hero in the picture and y is the side hero or supporting actor. Okay. So so derivative of y is dy by dx, of course. Then okay, let's just write everything in derivative form. Everything in derivative form, because it is with respect to x, you will have d by dx in the denominator because it's in with respect to x. Okay, so nothing, I'm just copying this question and writing it in the derivative form. Okay. I have written this question in derivative form now. Now what is dy by dx? It's nothing but dy by dx simply. What is the derivative of sine? Sine derivative is what? Cos y into function considered as x. So it's dy by dx. Correct? You don't have x here, you have y. So I had to multiply. Then cos x derivative, I can directly find cos x derivative. Direct formula we know. It is minus sine x. Right? Now, can I take dy by dx as common from both the sides? Of course I can. So what remains here? Nothing. So 1 plus what remains here? Cos y is equal to minus sine x. Correct? Now, this is in multiplication. When it goes down, becomes division. So, this is your answer. This becomes your answer. Okay? Now moving ahead to the next concept, which is derivative of inverse trigonometric function. Again, this is also very easy. What we will do is we will derive one formula of sine inverse x, and similarly you can derive for other inverses for cos, cot, tan, sec, cosec. So we will derive only one, right? So here you have your function. Find the derivative of this. So your question is this, correct? This is your question. Using this, I have to find the derivative of this function. Okay. Now, what I'll do is simply, when this sine inverse, pay careful attention, when this sine inverse goes that side, what will it become? Sine inverse going that side will become sine y, and here you will have x left. So inverse going that side becomes a normal term. Okay, now I will solve. Now pay careful attention again. What is the, okay, now we will take derivative. We are taking derivative with respect to x. Okay. Now what we know is derivative of x is what? 1. Okay. Derivative of sine y. So I know derivative of sine x. Sine x derivative is cos x. But this is with respect to x. Hence, because it is y, I will have to multiply with dy by dx. Correct? Now, I have to eventually find dy by dx only in my life because that's derivative. Derivative is defined by dy by dx. So I'll keep dy by dx at this side. 1 upon cos y. Okay. Now one very simple rule I know is sine square x. So instead of x I'm writing y. It doesn't matter. Sine square x plus cos square x is equal to 1. Ninth standard trigonometry. So what is cos square y is equal to 1 minus sine square y. What is cos y? This square goes that side, becomes square root. Okay. So instead of cos y here, can I write root of 1 minus sine square y? Of course, why not? But what is sine y? Can I substitute sine y? Sine y is nothing but x. So instead of sine y, can I write x? Done. This is the derivative of sine inverse of x. Okay, similarly you can find the derivative for other terms. Okay, so see here. What is the derivative of sine inverse x? 1 upon root of 1 minus x square. That is what we proved. 1 upon root of 1 minus x square. Similarly, what is cos? Same as sine but minus. What is tan inverse? 1 upon 1 plus x square. Cot inverse? Same but minus sign. Similarly, sec inverse, cosec inverse is same as sec inverse, just minus sign. So this is the formula for all the inverse trigonometric functions. Correct? So let's just quickly solve one question on inverse trigonometric function as well. So this is your function, cos inverse you have to find. Again, you don't have x here. Okay, what is the formula of cos inverse x? Cos inverse x formula is minus 1 upon root of 1 minus x square. Okay, cos inverse x derivative formula is minus 1 upon root of 1 minus x square. So here again I'll write 1 upon minus 1 upon root of 1 minus x square. But again apply chain rule. Assume this as x. One minus x square. So this is my x for now. But then as I have assumed, I'll have to replace. So derivative of the function considered as x. Okay. Then you have minus 1 upon root of 1 minus 5x square into derivative of 5x. 5 is a constant term. Derivative of x is 1. So this is your final answer. Okay. You can of course open the bracket. So it will be minus 5 root of 1 minus 5 square is 25 x squared. Okay. It's that simple. Now let's just try more examples on chain rule. Few I will have you guys solve it. So I'll solve the last one and I'll probably solve the second one also. Okay, rest two you can answer in the comment box and let me know what answers you are getting. So this is your function. Okay, now I have to find the derivative of this function. So dy by dx is what I have to find. So d by dx of the question. So now I know what is the derivative of sine. Sine derivative is nothing but cos. Let me assume this function as x. Okay. So sine derivative is cos into the derivative function considered as x. So you have cos log x into what is the derivative of log x? It's 1 upon x. That's it. That's your answer. Okay. Now let's just see another question on chain rule. E raised to cos x is the question. Sure. So e raised to cos x is the question. So I have to find the derivative of this. Okay. What is the formula of derivative of e raised to x? It's e raised to x only. Derivative of e raised to x is e raised to x. So let me assume this function as x. Assume as x. E raised to x into derivative of the function assumed as x. E raised to x derivative is nothing but e raised to x only. Okay, that remains the same. The formula for e raised to x is e raised to x. What is the derivative of cos x? It is minus of sine x. Okay, now what we'll do is we'll just quickly differentiate a raised to x and derive what is the formula of this a raised to x. What is the derivative of a raised to x? So what do we want to find? This is your question, right? So we want to find the derivative of this. Before even starting this raised to x is irritating me. So I'm taking log on both the sides. Okay. And after doing so, what I have left is logs. This is the basic function of log, that if you have log and anything raised to, then it will come before the log. So this is what you have, correct? Now what we will do is, let's just differentiate now. So differentiating with respect to x, okay? Differentiating with respect to x. So what is the derivative of log x? It is 1 upon x. But since we don't have x here, so derivative function considered as x. Then you have x into log a. So log of a is a constant sum. Log of a will remain as it is. And derivative of x will become 1. Correct? So now what you have is dy by dx is equal to, this is what you want to find eventually, right? Dy by dx has to be on this side. So 1 upon y, when goes that side, comes into multiplication. But, what is y? What is y? Y is nothing but a raised to x. So, the derivative of, a raised to x is a raised to x log a. For example, you have 2 raised to x and you have to find the derivative. How will you find? 2 is your a in this case. So 2 raised to x into log 2. This is just an example, but your theorem ends here. Okay, so this is the formula for a raised to x derivative. Okay, let's move ahead. Okay, this is a very beautiful question. So you have theta, and now you're not used to looking at what theta is, but you will have to differentiate with respect to theta. You don't have x here. Remember, you used to find dy by dx, but you don't have x here. So what I will find is, first I will find dx by d theta. Okay, so a is a constant, will remain as it is. What is the derivative of cos? It's minus sine. Okay, this was my first step. Second step, I will find dy by d theta. What is my y? So a is constant. What is the derivative of sine? Derivative of sine is cos. This is your second step. Very simple. But this is not what you want to find. You want to find dy by dx. Correct? You want to find dy by dx. So how will you find it? Very simple. Dy by d theta. So y is in the numerator. So make sure here you write y. And dx by d theta. What is dy by d theta? It's a cos theta. Upon what is dx by d theta? It's a minus sine theta. This and this gets cancelled out. Minus sign remains as it is. What is cos upon sine? Cot. So this is your answer. Very simple. So this is how you deal with whenever you have anything related to theta. Okay. Now let's jump to what a second order derivative means. Okay. So let me again take one example for this question. It's very simple. First, you have to find the first order derivative. So solve it normally. So you have this as your question. dy by dx is equal to d by dx. So this is how you find it normally, right? What is the derivative of x cube? 3x square, x raised to n formula, nx raised to n minus 1. Plus, what is the derivative of tan x? Tan x derivative is sec square x. Done. This is your first order derivative, as in the degree is 1. Okay. But I want to find what? Second order, which is degree 2. So to this, I'll again differentiate. So d by dx is the differentiation term. Again, I'll differentiate this. Okay. Now what will this become? This will become d square y upon dx square, and this will become d square upon x square. Okay. Now 3 is a constant term. X square derivative is 2x plus this when I have to find sec square x. So what is the derivative of sec x? Sec x derivative is sec x tan x, correct? Or you can alternatively solve this as, so you don't know the derivative of sec square x. There is no derivative of sec square x. So to this sec x, I'm considering this as x. Assume this as x. Okay. That means you have to find the derivative of x square, correct? What is the derivative of x square? It is 2x into the derivative of function considered as x. Correct? This I assumed as x. What is the derivative of x square? It is 2x. So 2x into chain rule into derivative function assumed as x. Okay? Let's just solve further. 3 2s are 6. 2 sec x. What is the derivative of sec x? It is sec x tan x. So your final answer turns out to be 2 sec square x into tan x. This is how you find the double derivative. First you find the first order derivative, and then to the answer of the first order derivative, you again take a derivative. Okay, pretty simple. Now how do you find inverse functions? This is also pretty simple, very simple rather. Let's take example to understand better. First, I would like to explain a small concept, which is if you have cos inverse into cos x, so this cos inverse cos gets cancelled and what remains is x. Similarly, if you had sine inverse and sine 2x, so this and this will get cancelled and the remaining will be 2x, correct? So your question is cos inverse of sine x. What is my goal? My goal is to cancel. My goal is to make the bracket as cos x. This is my aim. Okay. Now let's just solve this question. Cos inverse of, this is a formula that you have studied in class 10th. Sin x is also equal to, this is a formula, straightforward. Sin x is also equal to cos of pi by 2 minus x. Okay, so instead of sin x in the bracket, I am writing cos of pi by 2 minus x. I have not even started derivative. Okay, now cos inverse and cos gets cancelled. What remains is pi by 2 minus x. Okay, then what is the derivative? Now I am finding the derivative. This is a constant term, 0 minus, what is the derivative of x? 1. So your answer is minus 1. Okay, let's just take one more example so that inverse function will be super clear to you. Okay, now my aim is to make this bracket as tan. Okay, That is my only aim, so that tan inverse and tan will get cancelled. Okay, so for this I will apply again trigonometry. Trigonometry simple formulae that we have studied in class 11th. Okay, sine 2x formula I know. Okay, sine 2x formula you must have studied, which was 2 sine x cos x. But you don't have sine 2x here, you have just sine x. So this 2 became half. So this will also become half. 2 sine x by 2 cos x by 2. This is something which is a part of trigonometry chapter. Okay. So if you don't know half angle formulae, please go and revise. Similarly, 1 plus cos x formula is 2 cos square x by 2. Correct? So now what will happen is 2 gets cancelled. 1 cos and 1 cos gets cancelled. What remains is sine upon cos. Correct? Just carefully pay attention on what is remaining. Tan inverse of sine x by 2 upon cos x by 2 is the remaining term. What is sine upon cos? 9th standard trigonometry. Tan theta, tan x by 2. Tan inverse and tan gets cancelled. X by 2 is the remaining part. And now to find the derivative of this, so this 1 by 2 is constant and derivative of x is 1. So your answer is 1 by 2. So these are all the concepts. I hope we have covered all the concepts, and you have any doubt you can put it in the comment section. Bye. See you in the next video.